Okay, before diving heavily into the rules for different types of interconnections, let's talk about the concept of backfeeding because it's something we're going to see over and over again, regardless of how we interconnect, because we're not a load. We are a power production source. We're operating in parallel, but we're often going in the opposite direction that primary power sources are used to. They're used to delivering power rather than receiving it, thus backfeeding. So backfeed. We've got a couple of pictures here that are some good examples. This would be what we'll get into and call an AC combiner panel, perhaps, kind of into slang, if you will. We've got 4 inverters. There's 1, 2, 3, 4 breakers, 3-phase system here, and those are being backfed. Inverter output is coming into the breaker and onto the bus bar, and then down to the primary power source. There's our main breaker in this panel, as opposed to what we would call normal flow, which is from the primary power source through the main breaker onto the bus bar and out to the loads. You can see in this one, there actually are no load breakers in this panel. Here's an example with fuses. So backfed fuses from a larger inverter. We've got our primary power source connected to the line side of the switch on the top here. We've got the switch itself, and then we've got fuses as our overcurrent protection devices, and here's our inverter connections to each of the 3 phases. So primary power source here, normally it would flow from the primary and then to through the fuse and out to whatever is connected here. In this case, of course, with our interconnected power production equipment, we are generating power and we are pushing back against the primary source, not the normal direction of current flow, thus backfed or backfeeding. Okay, so here's a diagram of it if it's not already clear enough for you. Primary power source on the top. It is coming in through the main breaker here and then going out to the loads. However, in this case, we've got our load side connected PV system, and it's pushing backfeeding through that breaker, backfeeding through the main breaker, in fact, backfeeding in some cases through the meter to the primary power source. Not always, and depends on the size of the system and how much it's making and what the load is and all that stuff, of course, but you can imagine that could be the case. Okay, so it's not the normal direction, which is from the primary source to the load. Backfeed is that opposite direction from the inverter to the primary source. Now you'll notice in a lot of the diagrams we're going to show here, we are calling it an inverter. We're not saying PV system, because you want to keep this in mind. The rules in 705 are not PV system specific. Otherwise, where would they be? They'd be in Article 690. They used to be in Article 690. But it could be the source of power. It could be anything. PV, microhydro, fuel cell, whatever it is. It's probably coming through an inverter to interconnect to the primary power source. And the rules are going to be the same regardless of what's generating the electricity that's supplying that inverter. Okay, 705.12d for load side connections talks about devices that are suitable for backfeeding. So fuse disconnects, unless they say that they're not suitable for backfeeding, are going to be okay to backfeed. Circuit breakers that are not marked line and load. So the plug-in style breakers you see on the slide here, they're never, in my experience, marked line and load. It's kind of obvious what's the line side, line being the primary power source side. That would be the side that connects to the bus bar. And the load side, well, that's where you connect the wire that runs to the load. Okay, so it's pretty obvious just inherently in their construction. But the idea here is that a breaker that is marked line and load has only been tested for current flow in one direction. If it's not marked line and load, it doesn't care which way current flows through it. If it is, it may not operate correctly when current goes the opposite direction when we backfeed it. So, circuit breakers not marked line and load, okay. If they are, they're not okay. Not okay for backfeeding unless, right? So we could have circuit breakers that are rated, tested, and listed for reverse current, even if they're marked line and load. Once again, you're going to hear this over and over. You got to talk to the manufacturer. Talk to the manufacturer. If you've got an overcurrent protection device in the form of a breaker that says line and load on it, talk to the manufacturer. We've seen this over and over again, particularly with ground fault breakers. Some large services, the main breaker is a ground fault breaker, and it has a line and load marking on it. But the manufacturers have done the testing, and their product is okay for backfeeding. It may not be obvious. You may have to dig down and find that. And if you just look at the line and load, you might say, oh, I can't do this. and that may limit in terms of how you can interconnect. You may have to be connected on the supply side instead of the load side, which could be more expensive. So always talk to the manufacturers of the specific breaker that you are concerned about when it is marked line and load. It very well may be okay. You just need to get approval for that. Okay, let's also talk about fastening. When we backfeed a breaker, sometimes we have to fasten it into place. So 408-36D says that backfed overcurrent protection requires an additional fastener other than the pull to release type fastening. Okay, so the pulling the breaker off of the bus bar is not enough. The cover that you can see on this one on the right-hand side here, right, that's the metal cover that kind of holds the breakers in place. That's not enough either. That's not enough either. So those breakers, in some cases, would need additional fastening when they're being backfed. And this kind of makes sense. Let's say that one of these breakers here is connected to a generator, and you're backfeeding it from a generator. Well, what happens if I take that breaker? Let's pretend the fastener's not there. It's just a regular plug-in breaker. The generator's running. I take the breaker, I pull it off the bus bar. What am I holding in my hand? I'm holding the output of the generator. That breaker is still energized. That's dangerous. So we are required to have breaker fasteners so that, you got to get a tool out. You got to think about what you're doing here. You can't just whip that breaker off the bus bar and be holding an energized breaker. Presumably, if you're a qualified person, you see there's a breaker fastener, you realize you need to shut down this power source before I do anything on that breaker. There's a couple of examples of different fasteners on the slide here that you can see. Now, 70512E recognizes the fact that utility interactive inverters, well, they don't operate when there's not a primary power source. Their interconnection to the grid is, when that goes down, they're required to shut down by the UL listing. So thinking back to that breaker that I pulled off the bus bar, if it's connected to an inverter, well, as soon as I pull it off the bus bar, I'm holding a piece of plastic and metal in my hand. It's not energized anymore. Okay, so this is kind of a common sense approach. We don't need to do this additional fastener because there's not the safety hazard there that 408-36D is pointing to. Now, a lot of inspectors familiar with 408-36D, maybe not as familiar with 705-12E, so it behooves you to know that you do not need to sometimes spend a lot of time tracking down these breaker fasteners, which can be difficult to get for some equipment and are not needed in the cases that we are going to be installing under. Now, it's not 100% true in the PV world, right? For a grid direct inverter where that inverter is going to shut off as soon as I pull the breaker off the bus bar, fastener not required per 705-12E. Now, there are some instances where if I'm backfeeding a breaker from a PV system, I may need to have fastening, right? A backup loads panel from a multi-mode inverter, which is made to continue operating the backed up loads when the primary power source goes away. So it has a connection to the grid. It has a connection to a backed up loads panel. That backed up loads panel is going to remain energized from the inverter when the grid goes down. So it's kind of like the generator example. Now that breaker that I'm backfeeding is energized. And so that's going to require that fastener, and standalone systems as well, where, we don't have a primary power source, or the standalone system is the primary power source. So it needs to be fastened into place because, once again, it's creating the voltage waveform. I pull that breaker off the bus bar that's being backfed. The breaker is still energized. Okay, quick look at backfeeding. Up next, we're going to start our heavy dive into load side connections. I'll talk to you soon.